All right, welcome back, everybody, to the Additive Snack podcast. I'm your host, Fabian Alefeld, and today we have another set of, in this case, two incredible guests with us, and both of them have shaped the AM industry for quite some time now. First, we're joined by Joris, the executive editor at 3dprint.com and vice president of consulting at Additive Manufacturing Research. And we have Max Bogue, the chairman and founder of Wobbleworks and the creator of the 3D Doodler, a tool that 3D Doodler, that has brought the additive manufacturing to a lot of kids and education institutes, but also is finding its way into a lot of interesting industries that we'll talk about in a few minutes here as well. They also together host the 3D Pod, where I was also a guest on a few weeks ago. So we decided to turn the tables and have them on Additive Snack. Therefore, we'll talk about many cool things. We'll talk about the state of additive manufacturing, its media outlets. We'll talk about applications, because Joris likes to talk about those, but also AM implementation and even potentially topics like the job market. So without any further ado, Joris and Max, welcome to Additive Snack.
Thank you.
Thanks.
Yeah, thanks for having us.
It's so nice to be here. Thank you for having us.
Yeah, it's awesome to have you guys. I had a lot of fun being on the 3D Pod. So yeah, excited to continue. Let's see. You're both now, whether you like it or not, media personalities. You're out there. You guys launch a lot of interesting content, and I'm kind of curious to hear your guys' opinion on where is the additive manufacturing or 3D printing media stand today. I think we used to go through a huge hype curve in the media. Last year we were in doom mode, or I don't know if we want to call it a demon mode even. And then right now I feel like we're maybe a bit back into having some more confidence into the technology and forward looking. What's your perspective on where we're at?
Do you want to go first, Joris? You want me to go?
No, go.
I mean, I think it's a similar kind of circular pattern, if you will, that we've seen with every other new technology that's ever kind of hit, where we initially have that massive hype curve, and now it's calming down,
Yeah.
but it's still obviously like in a hype up and down as it goes along. But I don't think it'll never be quite what it was like in the 2010s, the 2012, 2013 kind of era, if you will, when it was just at its peak. But this isn't that different from AI, quantum computing, transistors from the 1950s, the personal computer in the 1980s, where you see these like massive stories, and then it starts quieting down, and then it just becomes this normal thing that no one ever realizes is like surrounding them, and it took a whole bunch of effort to make it happen.
Mm-hmm.
Yeah. What's your perspective?
Yeah, it's similar. I think we're very definitely kind of in a well, we've now had it that we've kind of basically the desktop 3D printer was supposed to be the next big thing. That kind of didn't end up working. And then additive, let's say, was supposed to be the next big thing. That didn't end up working. I think I agree with Max, we'd be very too optimistic, I think, to hope that they'll come back a third time to kind of somehow rediscover us as the next big thing, unless we all kind of morph ourselves into kind of more that bioprinting, digital manufacturing for everything kind of, unless we come up with like a new kind of thing for them to believe in. I think now we really have to focus on, growing on our own merits. Right. So actually, it's not about the future. It's not about what could happen or what we should happen or what we could change. It's what we're doing now, and very concretely about what we can show now as being effective and as being cost effective. And especially with like lack of capex, companies being more careful, cautious, even investors being more cautious as well, and also investors having moved on kind of to AI and all this other stuff. I definitely think that it's going to be much more a question of us having to make money.
Yeah.
Right. And also, and so as a media, we have to talk not about like 3D printing can be cool for all the skateboards, right? No, we have to literally talk about, this is Jill. Jill is doing a skateboard startup. This is what she can do with this. Forget the TAM, SAM, whatever. No, this is what her business is doing. This is how profitable the business is. This is how it's growing. This is an example maybe of other people could do similar businesses in and many other sports brands, let's say, for example. I think we should talk more realistically and be much more about the personality, Jill, what she's actually doing. What is her, if we all have the same Bamboo Labs printers, or we all have access to the same services, what is Jill doing to make herself special, right? And we need to focus on other things. Like, for example, I'm working on like my own products now, and the thing that really hits me all the time is reach. How do I get reach? How do I get people to buy into this product, to test it, to find it? And that's not something that we can generate for ourselves. If we're talking about the skateboard, I would have to reach out to skateboard media. So we would need to kind of educate engineers on how to do that, for example. So it's a different kind of more how to do business, how to engineers to do business, or how to business people to work with engineers to get to the next level. I think that's much more kind of what we should be talking about, and will actually resonate with people now. Just like, you have all these, I don't know if it's like that where you live, but now there's all these companies where it's like Bob's peanut butter, and all those kind of people reinventing the peanut butter or milk or whatever,
But it's local.
And I think that is a bigger, exactly. That's a bigger trend that I think we could play a part of. And it's about like, how do we, in a media landscape like that, how do we navigate it with a 3D printed product, knowing that that's kind of more commonplace? Because for a lot of people, it's like, it's 3D printed was their entire marketing plan, right? And that's just not enough.
Coming back to that though, it's I mean, you're getting to the corridors where it's like the future of the media landscape is to basically make it boring on the 3D print side.
Yeah.
And that's what needs to happen anyways, because it needs to become not such a big deal and more commonplace at the end of the day. So it should be boring and less of a media story. Oh, they happen to be using 3D printing.
Yeah.
Okay.
Yeah. If additive is on the same level as peanut butter,
we've gone somewhere.
Then we've definitely made it. Yeah. Okay. I mean, we talked about this in the past too, right? Where boring is the objective, not the sexy, awesome applications, and also breaking out of the additive manufacturing echo chamber where we all talk to each other, but we don't reach the audiences that are outside of the additive manufacturing industry that actually want something boring to implement that is not rocket science. How do we reach those people?
I think the whole industry is like this one giant application specific thing. That was I did these RP RIP 3D printing articles, and the whole point of that is like we shouldn't sell boxes. It takes too long. It's too risky for the guy to buy a machine $1 million without knowing how to use it. It takes too long for the company to see an ROI. So we have a service for everything, right? So it's like press a button, get a 3D printed filter. And it happens to be a 3D printed filter, but it's actually like a filter that you use, I don't know, DLP, ceramic slurry, DLP, whatever. And it's certified. It does the things you want it to, but has a better flow, and it's easier to replace, and it's lasts longer. It's a bit more expensive. So for that kind of product, I think we should replicate that kind of product again and again and again. And there shouldn't be any kind of friction. The customer can just say, this is the size I need, this is the kind of conditions I need, and it'll get sent to me on Friday or whatever. So this frictionless kind of one-click applications, that's to me the future. So to me, it's like it's not about, it's like, okay, so that would be, well, who buys filters, right? So I don't know, like chemical industry, chemical people, chemical blogs about chemistry or factory processing or that kind of stuff, making medicine, pharmaceutical, contract manufacturing for pharma blogs, that's the kind of thing that I would look at. So to me, it's like it's industry specific collaboration and product development for really specific people. So we should find them wherever they are, right? So we shouldn't go, well, we should totally go to Formnext because we'll have to have a place to hang out. But we should go to whatever trade show these guys are at, and we should go to whatever magazine these guys are at, International Chemical Processing News or whatever, So to me, I see everything through that lens. Like everything should be a one-click application thing. And at the back, somebody somewhere is buying a machine, but that's a person who knows what they're doing. And they're going to buy this machine within a month. They go up and running, qualified, certified, and they're spitting out parts like crazy. And that to me will accelerate our entire industry. And that to me is the way to go. So I see everything through that. Like just like I don't think there's another option. It's just like we have to make it completely frictionless.
Yeah, reduce barriers of entry and ease of accessibility, especially when it comes to supply chain use cases, right? I mean, just today, all U.S. ports are down because port workers are striking. Right.
East Coast.
The next
East Coast ports are down.
or
East Coast
just
and the
East
Gulf.
Coast, but enough. Yeah,
It
enough.
matters.
Right. The next supply chain ripple effect that'll probably last 6 months is about to happen. Right. And more and more we see that's one of the key strengths of additive is to be able to at least buffer some of those critical demands through localized manufacturing.
Yeah, but I think that is nice, and I think all these digital warehousing guys are really got a great long-term business. It's very sticky, right? If you save a guy that one time with his East Coast port thing, you make all the parts, he's gonna keep using you, right? Because you've got them all qualified, or you've got them all in your digital system, you've got them connected to his ERP. He's never going to go anywhere else, right? Unless you rip him off. As long as you don't rip him off, it's fine. But so it's a really sticky business. But still, that is too frictionless. There's tools to help you score parts, right? But there's not tools to help you see if the part will print all the time or how costing would be. And it needs to be more automated. There needs to be more intelligence there, so you can really, literally say, all right, give us your access to your ERP tool, or give us access to your PLM, and we'll just load everything, and then we'll tell you what we can print when for how much. So we're getting there, but that to me also has to be frictionless. We can't just, you can't just have 10 guys go through all those files for months. I know there's people that are doing this, right? They literally have like 30 engineers, and all they do is look at these parts and see if they're printable. But I think that needs to be automated as well.
Well, it's more than just that, right? There's really two massive friction points. One is the beginning, software. Like there are not enough people in the world that know how to use 3D CAD for the purposes of 3D printing. So that has to be learned. Or we need to come up with a much simpler software system that allows you to more easily create the part files. And then, yes, we have to print it, then we have to post-process it. We always spend so much time and effort in post-processing too, that it needs to, on the physical side, printers need to be able to get to the point where post-processing is part of the print, if you will. That like when you get the part off the bed, it's done, automated and done. I think those are the two real problems at this point to making it mass adoptable, if you will.
Yeah, I think I totally agree. I think if you look at the whole value chain of additive, it still requires a lot of expertise and efforts to implement the technology. And I want to touch on the implementation a little bit later, because I think you guys have some really interesting experiences there. Before we go there, though, we talked about the media landscape, and I really do think last or this year even we've had a lot of negativity for good reason in coverage, right? I mean, this was a bumpy year for the additive manufacturing industry. Where do you guys think we're at right now? Have we hit bottom? Is there more bottom to go?
I think there's more bottom to go.
What's going to happen?
I think the closest equivalent you should look at is the PC boom in the 1980s. There was a section of Massachusetts that's a highway called Route 128. And it was Route 128, which is where all the small independent computer companies were located. And we're talking hundreds of computer companies that were all making personal computers. And the only one that kind of survived the Route 128 was Digital, or DEC, which was then purchased by Dell at the end of the day. And Microsoft took some of the software, which was then created into NT, which is Windows XP, which is then everything that we're running off of now. So I think you're going to see significant consolidation, and you're going to be left with dozens of companies, I think, at the end, and not hundreds of companies, because it's just going to reach a phase where it is such a barrier to entry, and it's so difficult and complicated, and the machines are going to grow in such a state, and that you're just going to have the right labor force behind it to help sell the items and to put them into place and whatnot. And it only makes sense at larger companies. And so I think we're still in that middle phase where we have mid-sized companies and small companies and a couple big companies. But I think it's going to tend more towards the big companies as it moves forward. But Joris, you may have a different opinion.
I kind of agree. Like generally, I mean, look at the car companies. Like in the beginning of the car industry, was it Peugeot, Ford,
Tucker,
Mercedes?
Yeah.
Yeah, I think those are the three that still exist, and Peugeot isn't doing so well at the moment. So but since then, a lot of other companies have come and then gone again, right? We shouldn't exist at we shouldn't expect like the people to just stop innovating and stop wanting to do businesses. One of my examples, again, I keep talking about this, is like the fact that there's Ivaldi and ThyssenKrupp's ThyssenKrupp's kind of joint venture Pelagus. They're the only companies I know of. Well, kind of like those containerized printer guys as well. I don't know, they're doing it, but anyway, there's no one else focusing on maritime. Maritime 3D printing is probably one of the biggest opportunities out there. It's been problematic because of part size and cost and all this kind of stuff. But there's only like a few companies focusing on that. If I would today start in Qatar or Saudi Arabia or in Singapore, start a company with Max making spare parts for maritime using DED or WAM, it'd be hard, but we'd be like the literally third company in this business. And there's lots of stuff out there. Like, for example, everybody has always been focusing on the car businesses, right? That's a horrible thing. I always tell people, clients, never pitch a car company because it's going to take you years. And they're very process driven. It's very difficult. And they'll cancel your project just like this because of some macroeconomic thing, whatever. Growth slowing in China. Bye. Or some weird thing, right? So we've decided to go another way, But what I always tell people is specialty vehicles. That's the future, right? Ambulances, fire trucks. Fire truck business is not going great, but any kind of specialty vehicle. Think of like your local transport service has like a kind of a adaptable for handicapped people. You can get your own car adapted to your handicap. That kind of stuff is a huge potential business for us. All these guys use a lot of like welding. Welders are disappearing, getting more expensive. They use a lot of sheet metal, which is also really expensive. We can use a lot of 3D printed parts as molds and in end parts there, right? And think about other like kind of like huge trends. Like we know that the biggest generation ever, these guys are going to need some kind of care. They're going to live much longer than other generations, right? Yeah. We're going to have a very few people to take care of them, right? There are already constraints on jobs. These are jobs that traditionally aren't caretaker jobs, or traditionally don't pay very well and are quite tough, actually. Yeah. So it's going to be really difficult to find these people. Now, robots notwithstanding, there's a lot of other solutions there that people could come up with using 3D printing, right? Nobody's doing this, right? Think about like robots, just another example. End effectors for robots, everybody always talks about it, but there's no website where I can go like and get for my own end effector, like the tool made immediately, right? I would have to go to an engineer, get that person to design it. She has to then like know 3D printing, and then it takes a long time, like Max said. So I think there's a ton more options there, but I just think the businesses are different. So if the first stage we were all doing servers, right? The server companies, Stratasys, 3D Systems, AOS. Now we're doing websites, right? Literally, right? But also kind of in the same thing that we're making content made for a certain person, made for them to enjoy and them to consume. Right, we're making the consumable, if you will, not the machine to make the consumable. And I think that's the way to drive growth. It's just to say, all right, well, I'm going to make your your assistive bathroom thing, or your whatever your the thing is that you want to create. So I think there'll be lots more different companies. Right, I see a lot of people wanting to be an OEM or a service bureau. I don't think either one of those are good businesses. They're very difficult businesses to get going on. And they're very difficult businesses to get investment in right now, right? So try something else. Try something application driven. Try something. I'm sorry, I'm going to repeat myself a lot, but try something like more like what be the website, And so imagine we were talking. This analogy doesn't 100% work, but imagine we're talking about the internet, and we're talking about Cisco maybe not doing as well. Cisco still exists, whatever. They still do well to a certain degree, but there's a whole generation of businesses that think of the Yahoos, the come and gone kind of businesses. Think of the Googles, the come and grown kind of businesses that still exist on the back of that technology. They didn't build they did actually kind of build some of the backbone, but they don't. I can buy technology from them as well, but they didn't build a server infrastructure for the internet. So that we're building like an application layer, if you will, on top of the infrastructure that's already been built by the OEMs and the services. I think that's where the money is. Look at Invisalign. That's perhaps 2 million prints a day. This is just like there's two guys with an idea, right? Oh, can we do this with SLA? right? There's tons of other examples out there. And my favorite example is hearing aids, over-the-counter hearing aids, but also hearing protection for professional things as well. Why is there no service where I can just get custom-made hearing protection for all of the guys on my construction site? Right? Headphones as well. It's a killer business. It's a horrible business, by the way.
It's not that much money in
very
it.
competitive. It's very competitive. But hey, there's very few people that are actually innovating through use of additive in headphones, even though we can make them more comfortable. So there's a lot of stuff there that can still happen. And also, you know what the cool thing is? That if we were the three of us start an OEM, we'd need money. We couldn't do this with our savings. We couldn't do this, or Max could. But we could. But if we would try to start a company making handmade 3D printed toothbrushes or something that are, or whatever, more ergonomic or whatever. Hey, but think of doing that for Parkinson people. If you made a Parkinson person toothbrush, that's going to be a thing, right? That is going to be a business, and that's going to be a business where if it works better than the nobody's going to want to buy the cheapest one of that. You're going to want to buy a good one. See, if we want to do a business like that, we could do that. We could develop that on our weekends. We could launch that really softly, really quietly. We could kind of grow that really generally, really slowly, and make a kind of, it doesn't have to, and it's also a little bit of a different business. Would it be a multi-billion-dollar business? We wouldn't need to be, right? It could just be a really
very limited business, though.
Yeah.
But
But imagine we did this. Imagine we did toothbrushes for Parkinson people. Right? Imagine the marketing. Right? We go to all the Parkinson foundations, all the things. We need a good domain name, good kind of recognition in that market. The doctors and the carers in the market would need to know us. I don't need to be on CNN. Right? I don't need to spend like X on all that kind of other stuff. I just need to sell a couple of these a day because, like, who cares, right? I mean, we sell one a day. It goes to the service. They make it.
You're also
so it's a different type of business.
You're getting insurance qualified and all that.
I'm not saying it's going to be super easy, but just like think about this as a business that runs in the background, right?
Yeah.
And think about us like having 5 of these, right? And the 5 of these businesses bring in a couple of different sources, and no, we won't ever have an airplane. But we'll have a living, and maybe we can make it meaningful, right? Maybe we could make a living out of assistive devices for people. That would be really nice. I would really like that, actually. Unless we didn't, we can't overcharge them.
But unfortunately, that's how that industry actually works. Is they are overcharged because of in the United States at least, because of the insurance industry in the U.S.
Almost everywhere.
Right. So there is like a Parkinson's spoon right now, for example, and I don't know what the price. Yeah. So it steadies the spoon,
super nice.
So you can feed yourself.
Yeah.
And something like that, though, I do a lot of work with the blind, for example, and visually impaired, and oftentimes their tools are in the thousands of dollars because not enough of them are made, and therefore you have to charge a huge amount of money because you're only making like 5,000 of this or 10,000 of that, and not 500,000 or a million. And that's when you get into those scales where the prices drop dramatically all of a sudden. But when you're in that 1,000 to 3,000 zone, that is like the worst place to be from a manufacturing standpoint, because it's going to cost you so much to set up the line and make the thing. And that's why tools like that are very expensive. But additive could actually jump in there because the cost isn't as much a factor in that particular case, and you're only making a few thousand of it. And that is a scenario where it's possible that additive would actually be cheaper in those small scale run type of scenarios.
Yeah.
Let me just quickly summarize that, and then I want to transition to your story, Max, of the 3 Doodler, because you kind of went that bootstrap route, and I think that's an important topic to discuss. But from what you just said, Joris, I think it's important to repeat. We've had an overflow of additive manufacturing OEMs in the industry, mainly also, I think, driven by an abundance of VC money that was available, especially during COVID times, but even a bit before. That money is drying up. I don't think we'll see another boom of that. Why? Because also, to your point, starting an OEM is capital intensive, and it's way more difficult than people think. And the parallels you can, I think, also drive to the EV market, right? Starting an EV company, many have tried it, from Faraday to Fisker to all those guys that now have gone under. And only a few like Tesla have made that huge leap. Why? Because it's so difficult to streamline the manufacturing process and produce repeatable quality. It, I also don't think that we'll
Or you
see
need state help,
more
like
OEMs
build
popping
your
up.
dream BYD. It's just the Chinese one, so
Yeah,
you know.
yeah. Also backed by
Right.
Warren, right?
Yeah.
There's a lot of capital behind it. But then the other parallel that I think is interesting. So OEM is difficult as starting an EV company, but starting an additive manufacturing application company is now kind of like starting a SaaS company where you can now use tools like AI, where I don't need 10 developers anymore. I need one or two, and I can run it super lean. If I think about manufacturing an application, I don't need to invest in tools and dies anymore. I can start somewhat lean and print my parts additively. And I could always flip the switch to conventional manufacturing once
Yep.
I reach a certain scale, right? So reducing that barrier of entry through now additive is actually an interesting lever that small companies and small entrepreneurs can use. Now my transition to you, Max. Tell us a bit about your experience on the
Sure.
on Wobbleworks and how you guys came to the idea, how you decided
Bring it to market the way that we did
to
it.
scale on a
Yeah.
smaller level versus going big and accepting VC money, and
Sure.
tell us where you are
So
today.
originally, I started Wobbleworks with Peter Dilworth, and we were an R&D company for consumer electronics in the toy industry. And our sole goal is to create concepts, get them ready for production, and then pitch them to companies. And I used to work at a company called WowE, which was a medium-sized toy company doing robotic toys for them. So I had a lot of contacts in the toy industry, and we would come up with fun ideas, and then I would go around to all these companies and pitch it. And we had, for example, a robot dinosaur based off of Peter Dilworth's work at the Leg Lab at MIT, Trudosaurus, which we call Trudy. And we were making a Trudy for Meccano, or Erector Sets, as it's known in the United States. And we were 3D printing a leg on a very old, on the first UPS printer. This is how far back we're talking here. And, and it missed a layer, as those early printers
Really?
had a habit of like doing, is you just miss a layer. And we had two perfectly good parts that just weren't joined together. And Peter, to his credit, said like, man, I wish you could just take like the printer head off of the printer and then use that to kind of like weld those pieces together. Why can't you do that? And we had one of those little head flapping moments where like, wait, why can't we do that? And so we quickly designed some parts in CAD, and then we had the printer print out the parts. And then we dismantled the printer and we used an Arduino and the print head, and we slapped together this very ugly, crude looking thing. And we were able to weld like the part together. And we're like, cool, presentation saved. And they're like, this is more fun. So we ended up buying another printer and parts and whatnot, fixing the old printer, and then we iterated quite a bit to make it into like a handheld, easy to use kind of device. And then we went off to all of these different companies to do a licensing deal with one of the major companies. And a vast,
because you never wanted to make a product, right? It was never the
we
idea.
specifically, having made product previously, I knew what it took to make product, and it is a pain in the butt. And I don't care if it's just a simple injection molding single piece of plastic or if it's like a whole thing. It's not easy and it's not simple. And I knew that, having worked for a company and doing that for a company for a number of years. And there were 100 people at WowE. There's this whole support staff, and it's like, we're 2 people. This is a huge pain in the ass. So, but Pete, to his credit, was constantly like, we should just do it ourselves. And we did. I pitched it around to all these different companies, and they were just like, I don't get it. Like, what would you do with it? And I'm like, oh, you make things. It's like Harold and the Purple Crayon. I'm like, yeah, but like, and do people want to do that? And I'm like, I think people want to do that, but none of them tended to want to go for it. And we were questioning it ourselves at the time. So we said, how about this? We'll put it on Kickstarter. We'll make a Kickstarter campaign and put it on Kickstarter, and we'll see how it does. And we basically we're asking for around 20, I think it was 20 or 30 grand. We needed enough money to pay for the tooling plus a little extra, because tooling is your biggest expenditure and all this stuff. And we just really didn't know what would happen. And we spent 3 months planning out the Kickstarter, and we did all this media outreach and all this press pre-prep and stuff like that. And then the day it launched, in the first 24 hours, it did around $500,000. And then by the time the campaign finished, we did around 2.3 million with 26,000 pre-orders. And we actually poured cold water on it at one point, because I knew what the ramp production rate was at the factory. And you give money to Kickstarter to do it. And at some point we're like, we have enough money. And what we did is we kept moving the next round of orders further out until we went to about 6 months out from the first delivery date, which people are less, they don't want to wait 6 months after the first one comes in. And we're like, good, stop.
But that's super advanced, because I think a lot of people, if you're new, you would have just gone
go for more, just throw it on,
go for
do it all. Exactly. Yeah. We had that discussion and I was very opposed to it. Having done manufacturing before, I knew that there were going to be problems. I knew that we were going to run into issues. And one of my biggest goals was to deliver the damn thing on time. Because once we finished the Kickstarter, I also knew we could then move on to retail. And we also took a similar approach on retail, where we were approached really early on by several large retailers, saying, and we just finished the Kickstarter, and I got these calls from major retailers saying, next year, let's put it in the store. And my response to them was, thank you very much, but it's going to be 2 to 3 years before I can go to you. And that was partially because I had to build a supply chain from scratch. And so I knew that I couldn't accommodate hundreds of thousands of units in the first year. I could only accommodate tens of thousands of units. And then we had to build everything up to get to that point where we could then accommodate hundreds of thousands of units and slowly build there. So we started with the Museum of Modern Art in New York City, the MoMA gift shop, because they do press for you as well. And it was a unique, cool item. Yeah. And we started with Brookstones, which only has 200 outlets. They're not around anymore, but not because of us. And so we did really well with those. And then we kind of built from there as we built the organization and then the surrounding stuff. And then in 2016, we introduced a kids version, which is not hot, so you can draw directly under your skin. It uses a PCL variant as well, so it's extremely safe. And it's battery powered and all that. And then we started getting a lot of inquiries from all over, and we started realizing that education wanted it, and we started realizing that consumers wanted it for the original purpose, which was to fix 3D prints and all that. So it's been 12 years. We are now in almost every major retailer in the United States, and we're doing lots of units a year. So we've sold around 5 or 6 million units to date on the 3D pen side. And it's a great introduction as well to 3D printing, to additive. A lot of, especially in the educational world, they're starting to use it as the pre-tool before going to 3D printing. Because you could export your CAD as a mechanical drawing, and that's essentially just a stencil. And then you can use your 3D pen to draw on the CAD, peel it off, join the pieces together, and then have an idea of what your three-dimensional object should look like and what the printer thinks it should look like. And then you can look at it and be like, oh, I screwed up. Oh, that's missing the screw hole. It's missing the door that I meant to put in there. And then that way you don't waste 12 hours or 10 hours on a print. And in a school environment, this is particularly important, obviously, because you don't have a lot of printers, you don't have a lot of time and all that. So you can do all that pre-processing. And people find applications that we never realized. Like the blind and visually impaired came to us saying, do you realize what you've done? And we said, no, please tell us what we've done. And I'm like, you can't do Braille with it. That was my first response. I said, you can't do Braille with it. And they're like, no, we don't want to do Braille. No one wants to do Braille. And it turns out they want to do raised lines on a flat surface. Any raised line on a flat surface. And so it's turned into tactile maps. The ability to give someone directions by writing it and then feeling it. The ability to write traditional letters and characters and feel those letters and characters, but a sighted person can just see those letters and characters. The ability to do different tactile textures and things of that nature. So it stuff we never would have come up with. I mean, we have a Build a Better Book program with the University of Colorado where we take children's books and we doodle on top of picture books so that a blind child can see the picture book for all intents and purposes, so they can feel it. So yeah, it's been fun. But
That's
the
so
core
cool.
of it was that we have no external funding because of the Kickstarter. So it funded the initial few years, which brought us through, and we were always a company focused on profitability. So we because we were two people in a garage, so to speak, we had to make it work. Otherwise, we weren't going to eat. In which case, when we did this over the years, we've been very slow in our growth and very specific to make sure that the growth corresponds to how many people we can actually support. And that we didn't want to take external funding because we've found from colleagues and friends and all that, when you take external funding, all of a sudden there's a demand from outside saying that you have to grow at this rate. You need to hire this number of people, even if you don't need them. You have to do it, and you have to listen to these people on the board that are going to say, take it this direction, even though they might not know if that's the right direction or not. That's just kind of their best guess, which is totally fair. And they're not focused on just you, they're focused on 100 other companies because they only need one company to succeed. They don't need all 100 companies to succeed. I always say it's like the Rambo model, like you put 100 soldiers in the field and only one comes out to be Rambo. Everybody else is dead. Whereas if you took a different approach to the model and said, how many of these companies need to be self-sustainable and slightly profitable versus, like a family firm, if you will, versus it needs to do explosive growth. But external investment generally wants explosive growth at the expense of everything else. And therefore you kill off the rest of the other companies in the process of getting that one unicorn to pop out through that model. But yeah, so.
Yeah. I mean, it looks like you followed that process that we just talked about earlier, right? Where you even leveraged
We
additive
did.
for your first prototypes.
We used the printer
Yeah,
to print the
yeah,
printer. Yeah, exactly.
yeah,
So,
yeah.
and yeah.
And then, yeah, where are you guys today? I mean, how many you've sold? 6
Around
million
five
pens, I think
point
you said.
something, so almost 6 million pens have been sold to date.
Okay.
We have four verticals. I forgot about the fourth vertical. We have the $3 start, which is for kids. So it's in education, it's in the toy market, and it's in hobby and craft. We have the $3 flow, which was based off the original pen. So this is like the 7th generation of these pens now. They've matured a lot. And so that's used more like for teens and high school and even college, as well as designers and prototyping, and for fun for like kids as well. And then we have a professional pen, which can do basically every material that will go into a desktop 3D printer, and because you can set the speed and temperature. But in some ways, it does a better job, like with wood, because you get imperfections, just like real wood. So as a result of drawing in wood, you're going to get a more realistic feel from this than you do from a 3D printer, because it's always the same thing. And then we have sugar. So we have the $3 chef, which is a pen that draws in sugar and isomalt and allows you to make sugar springs. Use it almost like a hot glue gun to like join pieces of cookies and crackers together, or to make a complete like Eiffel Tower out of sugar. You put pellets of sugar in, and then you get to eat it. But what it really is that one especially, that's a labor-saving device. If you were to make a traditional drip Eiffel Tower, you put a pot on the stove, you throw some isomalt into it, you take a spoon, and then you drip it out onto a stencil. It's like a 12 to 15 hour process. Using the pen, you're talking about an hour and a half. So right off there, you're like,
Cool.
So there's lots of like examples like that. So in some cases, these things are saving people time and effort. In other cases, these things are fixing things, and in other cases, it's just entertainment for kids.
Awesome.
I'm
I gotta get my son.
Yeah. You said you want.
Go ahead, Joris.
Yeah. Oh no, I was just really curious. Like about Max's like. So you said no a couple times.
Did.
You said no to the VCs. You said no to like accelerating this thing. You said no to the retailers. How did you know when? So saying no is super important. We know this. Like saying, but how did you define success for yourself? And was this not success, or did you just like look at it very practically? Like at this point, this doesn't make sense. How did you know when to say no to what?
I had experience, because I worked for another company that paid me to learn those lessons for them. And I saw numerous times when they wouldn't say no because it was an opportunity. And then I saw times when they did say no and realized that they were doing the right thing by saying no. And so a lot of it was realizing what was required to get to the point to sell to a Walmart or a Target. Like you need a lot more happening and a lot more people surrounding you to do things like manuals and activity guides and websites and all this stuff. And so I knew that we had to build in order to reach and scale to those sizes. And so the no's were largely centered around what was doable and what was not doable within realistic terms, being practical, because you only get one opportunity to be in these retailers. And if you screw it up, if you're late for delivery, it's a big detriment towards you, especially in the first year. And I've been in Target now for 6 or 7 years with the $3 Start series, and it does well every year for them, consistently. So they're very happy with us. But if I had gone too soon, I wouldn't have had that opportunity and created such a great relationship with them. So,
really good advice, especially for the folks out there who are thinking about starting an enterprise around additive manufacturing applications. It's also way more difficult to get funding today than it was years ago. So the path that you took may even be more accessible now. And like you just described, higher success rates, potential, and more continuous control over your organization. Now, not everybody, of course, has the ability or idea to start a company, but is potentially either tasked to implement additive within an organization, which has a whole set of additional challenges, from politics to budgeting to deciding where to start. Maybe asking you, Joris, because you also have a consulting role where you do help companies with their additive manufacturing endeavors. How do you typically approach a implementation project? What advice do you have to companies that you typically share?
Don't do it.
I knew that.
Don't do it. Don't do it. Thank you. This is my presentation, and my invoice is attached. No. The thing is, I think it depends on the organization. I think what first off, we have to realize that the people who we're going to make life hell for often have nothing to gain by improving it. So a production manager, a quality manager is not going to get a promotion off of this, right? Maybe the innovation manager, she'll get a promotion, or the whatever, the marketing guy that is behind this, right? These people, but the actual people who have to implement the technology often don't stand to gain from it. We're just going to make their life hell for 6 months. With an uncertain outcome, and these are exactly the type of people that don't like uncertain outcomes, because otherwise you're not going to do OEE for the rest of your life or whatever. So for these kind of people, you have to realize that is the thing. And so how do you make that organization win? And how do you reward or find a reward for these people? How do you make it as important as you could for those people? And most 3D printing implementations fail because of the change management part, or because of just what I just said, that the guys who actually have to put in the work and take the risk and the career risk and the monetary risk for their units or whatever often just don't get rewarded by it. So whereas the business development kiddo is like, oh my God, this is amazing. And the guy's like, I don't, there's no amazing bonus. There's no cool idea bonus. I don't get extra money for cool ideas. I get fired for cool ideas that don't work, right? So that I think is the one thing people realize. Now, the things that work, like the top-down approach works at some companies sometimes, but usually only in companies where management is kind of family-oriented or long-term oriented, or the business is long-term oriented. Think of like a Robert Bosch, where the only thing Robert Bosch does is sustain itself, or a Rolex, where the only thing it does is sustain itself, or maybe an AOS as well. Like kind of company like that has a really strong family influence at the top, and they can look a little bit longer than the next quarter, right? That's where it can really make sense, because everybody knows the boss is going to be around, right? So you might as well kind of finally buckle under this new initiative. Whereas if the guy's going to be gone in a couple of quarters, you're like, oh, okay, yeah, good idea. And then they'll just bide your time. So that's the other thing. Now, so top down rarely ever works. Bottom up works, but it usually is spontaneous. The example is a guy at a Ford plant brings his Ultimaker to work and shows, hey guys, this is how I made a thing to align the signs of the Ford mark on the back of the car, and we could save money, right? That has to be quite spontaneous. These can run into problems as well. For example, the Ford guy happened to know some CAD. Normally, a production engineer type of person, or these kind of people like working on the line, would not really be educated in CAD. They just probably would have a different kind of educational profile or whatever. So these kind of things that kind of have to rely on luck. Now, the only thing I know that where you can engineer luck is either go looking for these things, right, and looking for these examples where people are spontaneously doing it and then harnessing it, or to create kind of tools to accelerate the adoption. So, for example, in an academy, I've said this before, to have a table. Ferrari used to always have a table of broken things, right? Literally, physically a table with all the 3D prints that didn't work, plus the little card saying this is PA12, this is made on an AOS P110. It took 18 hours, and we get it from a service. It would cost $128. If we do it internally, it would cost $56. And it didn't work because of Y, X, Y, Z. All right. Also, things showing the minimum detail and max build volume, big X or whatever, and just showing all the stuff that went wrong and some of the stuff that went right. The next thing you have to realize is if you want that thing to really grow in the business, you're going to need a kind of thingiverse. You're going to need a mechanism to, one of the problems was working for a company, and the problem was that they had a SharePoint, but the SharePoint was more for like the corporate type employees, like the people, and then there was like a lot of people that were on the actual manufacturing layer that were kind of like really ambivalent / not on the SharePoint, right? But if they had to change a file, you couldn't just share a file without using the SharePoint. All right. So then all of a sudden we were like talking to SharePoint consultants. That, by the way, is something I would not recommend you do for fun. But anyway, so it's these kind of mechanisms. What's that mechanism for them to share that file, right? And how do you know it's the right one? How do you know it's the right printer, the right settings, the right filament, right whatever, the right service bureau, the right contract, whatever. And also, like, how do you celebrate success, and how do you define success in that organization? How can you make these people successful, right? Can you show that Mary, who does maintenance in the Philippines on our maintenance crew, is helping keep the place cleaner by making 3D prints that everyone can make, right? Can you then tell people that it took her 6 hours and it took them $28, and to give them a realistic example? Because what happens is if you try to inspire people, you're going to spend a lot of time saying no, because it's too expensive, too cheap, too whatever. And so you have to inspire them kind of with the real stuff that actually works. And often that's really kind of boring. We make housings, we make clips to hang up stuff, we make improvised stuff. It's all kind of the same. The stuff that really works in a company, right? Now, the other thing you could do is to do a big project. The new car is going to be 3D printed parts on it. That's also a really recipe for disaster, and also often goes wrong. So what I advocate doing, the only approach I think, is either the assisted bottom up, and I've changed my thinking a little bit, or what I call the sandbox. And the sandbox, I think I can come up with a fake example. I still have none of these I can talk about. It's called, I have this example, I used it before, so sorry if you've heard this before. It's like the ski tractor example. So imagine you're a tractor company. Let's say John Deere. John Deere actually is really great user of additive, but imagine like a not so additive John Deere. And you just go to them and say, hey, look, is there some kind of thing we're saying no to, or a sales guy saying no to a particular customized version or a tractor that we really think we could make? And then somebody says, yeah, it's a ski tractor. And it's for ski resorts. It helps get snow up there, snow cannons, cannon to make the avalanches go. And, you need a lot of custom parts for that. It's not really seem viable in the way we do things. It doesn't work process-wise because our process is too expensive. Right? Our process for evaluating parts is too expensive. It takes too long. A lot of times when we look at like a Navy or an Air Force implementing parts, they don't care about the part cost. The process may be too costly for them and too long. So what you say is, okay, you know what? We can make a ski tractor partially with additive. We'll make some molds. We'll make some end-use 3D printed parts. We'll make some rapid injection molding kind of parts, some short run kind of things. We'll make some end-use parts in sintering. We'll make some end-use parts in ABS, whatever. Right? And then we can make 6 ski tractors. So what I'm saying is that it's a well-defined kind of think as a well-defined project to just make 6 examples of a ski tractor to see if it works, to see if we can sell them, and to see if the customer is happy with them after 2 years or whatever. And so that's a kind of a sandbox project. Whereas the risk is defined as these 6 ski resorts being completely pissed off at us and wanting their money back, right? Or it's that it doesn't work because the fuel tank that you wanted or the fuel tank holder that you wanted doesn't work, which of course could be very problematic in a vehicle, by the way. but we're not going to make the future John Deere 6000 tractor with additive, right? We're not going to run roughshod over production schedules and people doing it. We're just going to do a special little thing that's going to get everybody understanding the technology, right? And then they'll work with JAWS Tech, or they'll work with AOS, or they'll work with PA12 or whatever, and they'll understand more of this, and they'll understand that SLA is good for some things, and that the DD is good for some things, and that you could post-process these parts yourself, and then the other ones are too porous, you know? And that to me is the one thing that really works, finding that sandbox, but it's pretty rare to actually be able to do that in a meaningful way. But otherwise, you're just going to be riding roughshod over everybody's little empire, and it's just going to go nowhere. I mean, I've seen so many things go nowhere where everybody's like really like happy bunny, and then it doesn't end up actually making any kind of meaningful business example. You end up being like that. We redesigned it for additive. It's way more expensive, and it's now a desk toy on the 7th floor. Congratulations. Did you enjoy the last 7 months of your life?
Yeah, you need to encourage that. I mean, almost what you're talking about is an intrapreneurial approach, right? We're starting a small little, I don't want to call it a company, but project around a user need that we've identified that additive manufacturing may be able to satisfy, or may help us to produce call it an MVP that can be tested in the market, and then may or may not be produced even with additive, but allows us to get some traction with end users. That's a good advice.
Yeah, totally. Something like that. Something that makes it like more meaningful than just a prototype, or makes it a prototype that would work in that organization, right? Yeah. So something that makes it like live in that organization. I think that's really important, because then you don't, try and ram it down somebody's throat that doesn't want it. And you're also understanding what the sensibilities are of that organization, and maybe it'll take time. But again, like I think analogous to what Max said is like, you can only introduce this technology once. And if you make something that works, no matter how limited the impact is, what you don't want is a really expensive desk toy that everyone's going to look at, oh God, we tried additive, that sucked. Or you don't want, what people do a lot is to buy machines too early and not know how to operate them. And there are a lot of additive machines out there, often some really expensive ones that are just sitting in a corner doing absolutely nothing. And that's just they bought a machine too early, right? Without understanding it, without having the people that understand it, without having the business value. And they're making more than just making a really expensive desk toy for an executive. They're just have this thing gathering dust. So I think it's really like, it was a joke. It was a friend of mine. We come up with this joke: like, if you have an innovation department, you're not innovative, right? And it's kind of mean, right? It's kind of mean, but at the same time, it's kind of like, everybody should feel empowered to innovate, and everybody should be able to. Yeah. And a lot of organizations you can't. But I understand that if you're on Pfizer on a production line, you don't want some dude to be like, "Hey, it'd be cool if we could just," I understand. There's organizations where you don't want them to change anything, right? But there should be an outlet, right? There should be a place for that to happen, and a place for them to innovate and do that. And it's not necessarily, I don't think the best approach is to have that in one department. I think the best approach is to have that in a kind of, another mechanism. Like, I don't know if that's still the case. Google had that 20% time.
Yeah.
Like, that kind of a thing, like more where it's like more like or there's a budget somewhere floating around where you can do crazy things, right? Or some kind of like thing where really the employee, because often the people that are as close as possible to the actual process that really understand what it needs to conform to, what it needs to do. And if that person doesn't have an outlet, then it's also not going to be the type of thing that an innovation manager would really focus on, because it's usually a really small thing, right? It's usually really it seems an inconsequential thing, but it's important to that person and their job, and that's why it's so important to do it with additive, because we probably can't do it any other way, right? No. But at the same time, it's going to seem like not really a big thing, and it's going to be like, why would you want to make a housing for that? Or why would you want to make a clip so all the tools hang up on the, or why would you want a drone to fly around your factory inspecting everything? Like, why would you want to do that? Or why would you want to do holders for stuff?
Yeah. But in that regard, additive is not special, right? If you struggle implementing any other new technology, you're also going to struggle to implement additive. And if you're an organization that allows its employees to have that creative freedom to test out new ideas and fail, but fail fast, then most likely you're also going to be somewhat successful implementing additive. So that culture perspective and change approach that you mentioned, I think is probably the most important success criteria for an organization to implement additive successfully or not.
There's also this phase, it's often referred to crossing the chasm, where you have this early adopter section, and then there is a complete drop off, and then you get general adoption. And it's I think we're in the chasm in general. That we just got to get out of the chasm. I don't know when we get out of the chasm, but yeah.
I think that always depends on the industry. It's so hard to generalize this chasm approach to 3D printing or additive, right? I mean, it's even application specific.
Oh, 100%. Right? Yeah.
And die casting inserts have definitely crossed the chasm, right?
Making tooling with 3D printing is cross. Yeah, like that's a great application actually to like repair and make tooling quickly and fast that you just slip in as an insert. Wonderful. Yeah,
it's a beautiful application. Yeah, 100%.
Rocket propulsion.
Every rocket. No, that's true. Almost every rocket engine.
Prosthetics, orthopedics, orthotics.
Yeah,
hearing aids. But I think the only industry we're in, like it's either new space, if you consider that a separate industry, or dental. Those are the only ones where we're like everywhere, essentially, like on different levels, different products, all over the place. There's very few other things where we're like all over the place. And there's other ones where we're kind of already boring. Like we were talking before about boring. In jewelry, we're boring.
Yeah.
Right? We're boring. Only it's like a super commoditized process that's going on and very far away from prying eyes. But it's boring. Right? So I agree with you, Fabian, that it's totally different depending on what industry, but also what company in the industry and what they're doing. And it's a very kind of, if you look at the granular picture, it's very different than additive sucks at the moment. Or, it's not the case for anyone, the guys at the Air Force Research Lab. They're fine. They're happy. So that that's there's different horses for different courses, I think.
Yeah, and therefore we also we underestimate the maturity of additive in certain applications, and we overestimate the maturity in others, right? Because some industries talk about it. I mean, saw for the first time SpaceX showing the Raptor engine, and everyone's like, "Oh shit, this is 3D printed." They've been doing this for years, right? They just haven't talked about it. And then every time there's a new Adidas shoe, everybody freaks out, and it's the best thing. But it's actually not as it's a 0.1% probably of Adidas's shoes are printed, and I'm probably
the basketball is one of the best example, right? Where they made 500 or something like that. They're not going to make any more.
Yeah. And therefore, speaking of that, is there an industry that you guys wish would adopt additive more? Is there an industry that, Joris, you would love to consult because you think it's exciting and you think there's a lot of potential? Or you, Max, from your perspective, you also now are in a very specific sector in additive. Where do you want adoption? Where do you think it would be exciting?
Missile defense. Landmines. We're amazing.
Actually, that is a decent one because you can make thousands of something that crawl across a field, and then if you use beam robotics plus 3D printing, I think you could definitely take out a landmine.
Automated landmines. Yeah. I think all the scary defense stuff. Not that I want it to happen, but I think it's going to happen. So other stuff like, I don't know, like I'm about to choke actually.
I think robotics is already there in the sense. It's just robotics isn't big enough as an industry yet. All these new humanoid robots, I mean, everyone's competing really quickly. Tesla, Google, like everyone's trying to come out with this robot that's all being driven by 3D printing. And I don't think you could do it any other ways. Even Boston Dynamics only can make Atlas because they're printing with the hydraulic fluid as part of the print process. But they don't talk about it. So we have no idea how they're accomplishing it or whatnot. That's one of their secrets.
The Okada robot as well, the Okada robot, which is smaller, so it's able to go in this netting. It's able to make a ton of different parts, a ton of really complex assemblies. It's really beautiful because it's the duck case for these complex assemblies for 3D printing, and these kind of things like these little robots. And it's very, I agree, Max. It's very in the bowels of the company. So I think, robotics should be, a better example. They should be like talking about it more, and it would be much bigger, I think, if they did.
I think we're going to see an explosion in drones and 3D printing. Like we're already kind of seeing this at the beginning of it, but especially to move away from, as the Defense Department, the U.S. Defense Department is what's driving this largely, as we move away from the supply chain that requires to get, for example, motors from China or get these specific parts. And there are orgs that don't want to be reliant on exterior supply chains like the U.S. military. And therefore, they're going to drive, I think, a whole bunch of manufacturing on that level. There's a bill, for example, in the U.S. Senate right now that says that U.S. government agencies, be it education or military, can't buy Chinese-made drones anymore. So now they're going to be a bit of a cottage industry that's going to pop up as a result to make these drone components, if you will, outside of China. And one of the more interesting ones is going to be motors, because currently all DC motors
in the US
are made in China. And so, it's not that hard. You just need a winding machine and whatnot. And like Mexico makes big motors, but they don't make little tiny motors. And so that I think is going to be part of it, because I think there's going to be additive ways of making motors. And when it becomes a reasonable solution to do an additive motor solution, the whole...
Yeah, you guys probably have seen the Technion integrated drone engine that I think they even won an award for it as well. We printed one on the
new ion drones that are definitely ion power, where you're just taking electricity, putting it through a 10,000 volt line, and creating an ion thruster.
And to your point, Joris, in some ways, drones equals missiles nowadays, right?
Yes, that's what they are now. They're guided missiles, essentially.
No, so I'm running a report right now for additive manufacturing research on drones, and it is completely crazy what's going on there, and completely crazy how the volume and the cost factor, right? So American forces are talking about attritable drones, which are like $200,000. Right, and Ukraine are printing them for $150.
I was going to say the Ukrainians are,
and America are talking like the disruptor is supposed to print thousands in a year or something, and Ukraine wants thousands per day. Right, they have certain units that can only task 3 artillery kind of engagements in a, let's say, a set period, a few days. And if you can then have a thing that costs $200 that can change that for you. Right, we're seeing the development of this is so incredibly quick. It's incredibly rapid, and it's a lot of 3D printing driven. But at the moment, a lot of the electronics packages. So at the moment they're printing or laser cutting. Obviously, we have to say that as well. But a lot of them they're laser cutting the frame, right? And they're printing a lot of the other components, and also some in case of the munitions. But on a lot of the electronics, if not all the electronics packages in their entirety, come from China. And on either side, right? So it's completely crazy. And I don't really see how they can get away from that. It'd be nice to print everything. I think that'll take a while.
That several Ukrainian companies have purchased winding machines, for example, and you just need an SMTP machine. It's an expensive machine, and it's a big machine, but that's what you need to make the circuit boards at the end of the day. So I think, because of the 2 ongoing wars that are happening, and that in both of those scenarios, drones are becoming a massive component for the Ukrainians against Russia, the Iranians against the Israelis. They're sending in waves of drones, all of these guys. And that is what it is. It's going to drive this whole thing to a next level. So we'll...
I think it's interesting that the combined arms used to be something that only America could do. Like France and the UK could do it for a week. They'd run those spare parts, and now anyone can do combined arms. All right, and air superiority is something that the US had, for example, for billions of dollars. But now you could have air superiority over a country, but I could have it over a postal code or a building, and that's a really thing. And I could do combined arms in a postal code, and your really cool fighter thing couldn't shoot it down. right? Because it's like really small and very far away. So that's going to change everything. And I'd like, I don't know, I've been warning against this and talking about this drone thing and working on this drone thing for a really long time, since 2009 or something. And it's clear that the swarm thing was going to really, really be an effective thing. And now we're seeing it writ large. We're really actually seeing it kind of like actually happening. And it's kind of like, and this is our first big war where we're actually happening. It's actually happening and people know about it. A lot of the drones that are around today, even ones from the beginning to mid 2000s, are made using additive and a lot of components, fuel tanks, wing spars, wings, holders, some electronics components or components for electronics. They've been made since the mid 2000s already in a lot of these military drones, and because they essentially took the prototype and then went to fly it, right? And or they were like kind of like single use versions for use over Iran or whatever. And so that has been a long time coming, but now it's everyone knows it, and that's a really different thing. And I think that then people are going to think a little bit more, and you're going to think, obviously you're going to think the next step, right? They're already seeing ambushes. We're already seeing kind of approaches where there's like different types of operations with different types of drones working together. And of course, logically, you would want a buffer at one point of drones that are just doing their own thing, independent of whatever your strategy and plan is to disrupt the enemy. The best thing, of course, for you to not even know what you're doing to them all the time, and then to make a decision.
Automated
right?
weapons, though, yeah, is a danger.
Automated autonomous weaponry is a very scary,
a flying
scary
landmine
thought
for all intensive purposes.
Yeah, exactly.
But I do agree. It's changing warfare, and now you have a $500 piece of equipment competing with a $1 million US made piece of equipment, and that's a very interesting.
It's reminiscent. So in the American Civil War, it was huge loss of life, and part of that was that they were using very old school battle tactics of everyone get in a row and like start marching towards you, and this new thing had been introduced, the Gatling gun, which was the precursor to the machine gun. And that was kind of the first beginnings of the realization that like war had changed, if you will. And then you go to World War I, and the machine gun has been perfected, if you will, or not perfected, but it's now implemented on a battle scale, and this rushing across the front line, and you're just killing everyone. And it took a long time for the military leadership to realize this is not going to work anymore. We have to change the way we do this.
So
I think it's a similar thing.
There's
I think we
interesting-
moved faster,
there's interesting
though, in this case. I think you can see, like, this is warfare's changing, guys. Let's move over to drones, and let's move over to this swarm tactic, if you will.
Yeah, but there's an interesting thing there as well, because there's a lot of these guys, they dug up these battlefields and they find there's these ball and musket weapons, right? And what happens is the guy is reloading it. You have to reload it like this, and they would reload multiple balls of ammunition in the same gun without firing it. So they would go through the motions of firing it without firing it because they didn't want to kill anyone. Now imagine doing this when the other guy is charging at you with a sword or whatever. And so these people didn't want to kill people. But the Gatling gun, of course, is very obvious and you only have to find one guy that's willing to do this, and not everybody per se. And there is no kind of false reloading that thing. So it automated. It took away the will and kind of the inhibition to kill as well. And I think that's what we're also going to be seeing with these autonomous things. And I think it's completely inevitable, and it'll be. I think it's something you have to understand, like, what part do you have to play in this? Do you think this is like the future of your country, and you want to be like, you see it as patriotic to do this, or should we draw a line somewhere? Or do you think that this is going to be like a robot on robot war and no one's going to get injured?
Probably not, unfortunately.
Or do you see it as making war more likely because people are like, oh, okay, no pilots are going to get shot down, so let's do it. So there's a lot of things that I think could come off of this, and that's an industry that I think, I don't want to, because it's not great to see us. We were supposed to be printing,
tchotchke or
spinal pages
or
for
like
people
medical
and
stuff.
Yeah.
Nevertheless, there's also a chance that with increased volumes, additive becomes less attractive, and therefore you actually fall into some conventional technologies again. And there's a lot additional excitement around other industries. I am super excited about humanoids, like you mentioned. I think that's especially in the face of reduced labor availability, especially in the United States, but also in other
Or
Western
Japan.
countries. Right? There's also already companies that are now saying we will not sell you a robot, we will lease you a robot at an hourly fee lower than minimum wage, right? And that's
Yeah.
bam,
Wow.
That is the
bam.
solution.
Yeah, that's
Wow.
that is a crazy thought.
But in America, the minimum wage doesn't go up, so you're gonna have from a business model perspective, it's not great. Inflation is gonna kill you in the end. I wouldn't do that.
Depends on the state you're in.
Yeah.
All
Only
right, before
California
we
will have
wrap it up,
robots.
before we wrap it up, when I was doing some research on you guys, I saw an article by you, Joris, from 2010,
Yeah.
a guest post on TechCrunch on your 11
Ooh,
Oh
predictions.
wow!
that
Oh
could
no!
be. Yeah.
That went horribly wrong.
Yeah.
That was horribly. Oh my
Yes,
god! I don't
you
even
were very
remember that.
bullish on desktop printing.
Yeah. Okay. Good.
But before we go, what's your prediction, both of you? Each one prediction for 2025. What's gonna happen?
Wow.
We'll fact check you in here.
More consolidation. I think we're going to see a couple of the more popular desktop companies go under as well. Not to be a doomsayer here.
Ooh.
But
ouch. That's gonna hurt.
Yeah.
Okay. Yeah, more bankruptcies. And hopefully some applications. On the upside, some applications. Some application we haven't thought of coming to the fore, like bike seats, but not bike seats, right? But something more akin to this. Handbags or something like we haven't, something like literally something we haven't thought of. So it's more like from all the stuff we've been discovering, like conformal cooling stuff, something completely different that we haven't thought of. And I like that as much because that's a very hopeful thing. And then we'd be mature enough to help that person realize that vision, that weird vision that we haven't come up with ourselves. And then we'd be solving a problem that some designer, inventor, which she has in her life. And I think that would be my hopeful prediction. And we can make her.
That is a very good prediction, especially also when it comes to the use case you mentioned earlier, retirement homes. If we can find a way to improve people's lives further with additive, I think all of us would be in a very, very happy spot. Mm-hmm. I'm a happy spot because I really loved talking to you today. That was an awesome conversation. Thank you guys so much for being on the Additive Snack podcast.
Thank you.
That was wonderful. Thank you.
And also thank you out there for listening to this episode today. If you enjoyed it, please share it with friends, colleagues, and or family if they are interested in additive or also some side conversations. Stay tuned. We'll launch more episodes every week in this current season, and I will see you next time.